Hello, good evening.
Hey, how are you, man? All right, welcome to 5 Live Free Code School.
Okay, thank you.
Okay, so we got we're a couple people down. Jason will arrive shortly, and Ellen, I'm sure, will arrive. Let's go ahead and we're gonna do a little bit of setup that we can get them caught up with pretty quickly. So now that we're gonna start writing code, we have to have a little bit of a discussion about like, well, how do you have a place that you can practice writing your JavaScript? And the reason this is actually a significant thing to talk about is when you're learning this language, JavaScript, I found it really helpful to think about the fact that there's really only two places that it gets executed, which is kind of interesting. It either gets executed in a browser, because every browser has the ability to create an execution environment where you can convert JavaScript to machine language and run it on the client's computer, which is pretty wild and pretty weird and dangerous as all get out, by the way. Or you can use this runtime program called Node, and you can run it down on a server. Those are the only two places really where JavaScript is run typically. There are other limited options, but for any language, you need some utility there that can convert it to an executable. Well, when we're going to learn JavaScript, I really wanted to kind of just learn it as its own language without getting into too much of, well, here's what you do to develop programs for the server using JavaScript and Node, or here's what you have to do to set up writing programs that'll run in the client, in the browser, using the browser's execution environment. I don't want to get into that stuff yet. I just want to study the language as itself. So what I'm going to try first is a little utility called run.js. Have you guys heard of this before? Okay, let me show it to you. I've got to look it up. I think I have it installed on my machine, actually. Let me make sure I actually installed it. Something's going on with my search. I need to restart my machine because my Windows search isn't working at all, which is a lot of fun. So let's look this up. And I'll share my screen, show you what I'm talking about. And I might be getting the name of it wrong. It might be called Play.js. Is it Play.js? Run.js. There it is. Play.js, the Node.js and React Native IDE. I don't know if that's it. Run.js. I'll find it. Yeah, Run.js, a playground for JavaScript and TypeScript. Anybody know what TypeScript is? Have you heard that word before?
Yes.
Sudash, you're muted. Sudash, were you going to say something?
Yes, yeah, briefly. Yeah.
Okay. Can anybody describe roughly what it is? If not, that's fine.
It's not loosely typed like JavaScript.
That'd be a good way to describe it in simple terms, and that's absolutely perfectly appropriate. What it is a language that sort of sits on top of JavaScript. It was created by Microsoft, and it was designed primarily, has lots of other concerns, but primarily they wanted to deal with a language that has built-in types. And we talked a lot last night when we were looking at variables about this idea of different, native types of data. JavaScript has some native types, but when you create a variable, unlike some languages, in JavaScript, you don't have to define what type of data it is when you create it. You can just say like variable foo equals 375, or variable foo equals quote Eric Gross. And the JavaScript interpreter, the program like Node or the interpreter in a browser, can read through and intuit or figure out based on context what data type you intended. If you give it a numerical value, well, then you wanted a JavaScript built-in type called number. And if you gave it a string value, you want a built-in JavaScript data type called string, but you don't have to declare it. That's actually less common than the alternative. Most languages are typed. When you create a variable, you must assign what type it is. So TypeScript is kind of like JavaScript, but you can declare types for your data. And that opens up a whole different style of doing your code. There's other nuances to TypeScript. We're not going to get into that very much. Once you know your JavaScript really well, it's pretty easy to learn TypeScript. But I just want to explain what that term was, because we're about to use this run.js thing. And like I said, I'm pretty sure I have it installed, but I'd like you guys to go ahead and download it and install it. And I'll go to the download link and put it in chat. There it is. And maybe I deleted it. Let me go ahead and download it. I'm on Windows, so I'll grab the 64-bit. It's pretty small. You see, it's like 80 megs. I haven't used it a lot, so part of the reason I want to do this is just to get comfortable and adept at using it as well. But I've mucked around with it. I know it's perfectly fine for our purposes, being able to learn all these fundamentals of the JavaScript language. Look at this thing at the bottom of my screen. Oh, here it is. It's starting up. Okay, good. All right. Go ahead and let me know when you guys have installed it. It looks like it spins up after you install it.
Mine's installed.
Okay, good. And you have the same sort of interface I do?
Yeah.
Awesome.
Do I need to activate?
I think there's a free version. I don't know if I paid for it. I could be wrong. Show me your screen. Let me see what it says. Oh no! What do you see a prompt to activate?
No, not.
Oh, at the bottom there, activate run.js. No, yeah, we're not going to use it. By the time we get to more advanced things like Node Package Manager, that's what that first bullet point is, for example, we're going to be over into Node development and actually running our code in a real Node environment. I just want a little playground for us to only concentrate on the JavaScript language itself.
Okay. All
right, let me go and share my screen again. All right, and off to the side, I'm going to pull up my notes from the day before that I wrote on, let's see, I took notes on the 5 basic elements. There it is, 5 basic elements of any program. Oh, I changed the name of it. That's right. All right, let me just open up a Visual Studio Code window and I'll find the file because it's saved with a hash mark at the beginning, if I recall, which kind of messes things up. All right, so let's do file, open. And I believe I saved it right inside 5 Live Free Code School. Is that right?
Yeah.
There it is. Yeah. All right, so I'm going to have this off to the side. And we're just going to start going through some of these things, okay? First of all, remember that we have entrance point, variables, branching control instructions, subprograms, and an exit point. We're going to cover each of those. We'll jump around a little bit, okay? I will point out that on this page right here, that while you're not familiar with the syntax yet, we can find what the first line of code is. By the way, the first thing I'm going to do is figure out how to show line numbers. Let's go to Preferences, File, and then Preferences. There it is, line numbers. It's right there under General. Turn on your line numbers so we can see where everything's at. And this also shows us something pretty interesting. It looks like the first code that actually runs is on line 11. Now, again, before we get into too much of the nuances of what's going on line 8, just know that what we're doing is creating a function there. And the function is potential behavior. It sits there available as something you can do, but only when you call it. Just like we talked about last night with subprograms. You can call on them when you want to. Well, the very first instruction on line 11 actually goes ahead and calls that function called hello world. So in terms of, the entrance point, one of the more valuable things you can think with when you're trying to analyze JavaScript code is to just start at the top of the file and scan down and find the first code that will actually do anything. Line 8 doesn't do anything. No action is going to happen. We're just defining some potential action that could occur in the future. And so if you were like trying to understand what a particular JavaScript file did, that would be one approach. Start scanning through and find the first instruction that was actually intended to be executed. And then you can start stepping through, even in your mind, like a computer, going from one step to the next to the next. We'll see a lot more examples of that as we build more complex JavaScript files. But for now, let's just start talking about variables, okay? So I'm going to erase, I want you guys to all follow along. I'm going to erase a bunch of stuff here. In fact, I'm going to erase everything here. And we're just going to start, we've got our own little playground here. Now, what happens with this particular utility is that it's constantly, every single character stroke you make, it's seeing whether or not it can actually execute it. And if it does, it'll instantly execute it over on the right, which is kind of cool. So we're going to start learning about variables the way they were done prior to 2015. And I want to clarify, something very significant happened to JavaScript back in 2015. Does anybody have any idea what I'm talking about based on your previous studies?
In 2015, there came the ES6.
ES6. Okay, good. So ES6. Let's see if we can do some comments here. I think this is how we do some comments right here. So I'm going to give myself a little bit of room here so I can actually write some information. Okay. JavaScript started roughly about 1995. Do you guys know why it started? Why this language even came about? It's important to understand its history. Not just history can be dry and boring. It matters a little bit here. What was the impetus for creating this language? I mean, look, back in 95, we already had thousands of languages that have been created since the 60s. Why do we need one more?
It was made for the browsers to make web pages interactive.
That's spot on, Jonas. Now, picture it. It's 1995. You're a person who's making websites for people. And all you have are these technologies, what you've learned already. Now, you've been able to make some pretty cool pages. But here's the significant thing about it. Think about that HTTP request response cycle. The browser would send a request for a specific web page. That web page is stored on a server somewhere. The server finds the page. It's just an HTML document and maybe some CSS documents, right? And it sends those back to the browser, just HTML and CSS, and that's all. And the browser reads through them and renders something. It was the mid 90s, so probably lots of flashing lights and bright, bold colors, and it looked horrible. But that's all you had. So let's say you wanted something to change behavior on that page. Let's say, for example, when you rolled over an image, you'd like it to expand to be large. Sorry, I can't do it. No functionality. Well, you could have a little link next to it that says see larger version. But when you click on it, now the browser needs to send a communication down to the web server again saying, can you send another version of this web page? But it includes this one image in a large format. And the web server goes, okay, and it puts together that file and it sends it to the browser. And then suddenly your browser renders a whole new page. This one has the selected image much larger. As an example, it worked, but it was slow and cumbersome. Now I ask you, wouldn't it be a little bit easier to ship both a thumbnail of that image and the full version of it and only show the thumbnail, but as soon as someone moved their cursor over the thumbnail, boom, the large one shows? That would be kind of cool. That's the interactive thing. The page detected that the user did something. They needed some programming language to turn the browser from something really like boring, where the browser could only display the page as it was given, and that's it. And instead, make it a little more interactive. So they needed to come up with a programming language, because now you're talking about if, then, else. You're talking about variables. You're talking about entrance point, control and branching statements, subprograms. They needed one of those. And so several people and organizations started trying to make one. After a little bit of time, there were only two that really mattered. One was for a company called Netscape. Who's heard of a program called Netscape Navigator? This was the first truly successful browser. Netscape was started by a guy named Andreessen. Now, if you've been following technology at all, that name may be very familiar to you. Have any of you heard of a huge venture capital firm called Andreessen Horowitz? Anybody heard of that? They're a venture capital firm.
No.
They're in Silicon Valley and they're massive. Very often it's abbreviated A16Z because there's 16 letters between the A and the Z. So as you're following technology news, if you see that some startup got funding and some of the funding came from A16Z, you know it actually came from this company called Andreessen Horowitz. And Mark Andreessen created Netscape and made tons of money, and is still now, all these years later, what is that? Almost 30 years later, a huge player in Silicon Valley. So anyway, their company makes this Netscape Navigator, and they're like, hey, we need a scripting language. We need a scripting language, like Jonas said, to be able to make our pages interactive. So they started on one, and it had lots of names internally, but eventually, right before they released it to the public, they started calling it JavaScript. Anybody know why they called it JavaScript?
For marketing purposes.
Yeah,
Because
Jonas knows
Java
this.
was highly popular at that time.
Exactly. Oh, I think I covered that in that video. Yep. They were basically, it's called piggybacking on popularity of Java. Java was an incredibly popular language at the time. Still is, okay? JavaScript has nothing to do with Java. Zero, zip, nada, absolutely nothing. But Java was a really popular name. And so it just happened. I'm sure there's a story behind it, but JavaScript became the name. All right, now here's the problem. Microsoft was not very cooperative with the rest of the industry back then. They've changed over the years. They made their own scripting language called JavaScript. So for a couple of years, they were competing. The Microsoft browser, Internet Explorer, the worst dumpster fire in the history of technology. I hate it. I'll go down on record, don't care. Used JavaScript or used JavaScript. And then Netscape Navigator and maybe a few others were using this new JavaScript thing. And it was a real pain. And finally, as odd as it sounds, the European Computer Manufacturers Association said, hey, someone needs to make a standard for this, or the whole internet trying to implement this web and web browsers is going to have a major problem. They said, we need a spec. We need a spec, a standard. And they devised one. And it's called ECMAScript. Here's Ellen. Let's let her arrive. Hi, Ellen.
Hey, where is my video? Here.
Awesome.
Okay, sorry about that.
Totally fine. Here's how to get caught up. We're using a little utility that we'll spend a lot of time in called run.js. So let me recopy it in chat so you can see it. Look in chat and you'll find a link. Download the appropriate version and install it while I'm continuing. All we're talking about here is brief history of JavaScript, especially before and then after 2015.
Okay.
So right now, we're still before 2015. In fact, we're way back in the late 90s. This European Computer Manufacturers Association says, hey, we need a standard for this scripting language for web browsers. They devised one in coordination with both Netscape and Microsoft, and everybody kind of agreed, all right, this is what a scripting language will look like. So they published it. They did not implement it. They don't make software. Here's specifically what they said. They said, if you are a web browser company and you would like to have scripting capability and you want programmers from around the world to be able to send JavaScript programs to your browser and have them run with the expected behavior, then we highly recommend implementing in your browser a JavaScript interpreter that conforms to our standard. And with certain slight variations, most browsers agreed. It took a little bit of time, but eventually every major browser company said, all right, European Computer Manufacturers Association, you did a good job. We like this. We will build our browsers to conform to your specification. And that way, for years, JavaScript developers who were adding functionality to websites could write their code and expect that within reason, no matter what browser the code got shipped to, it would perform in a pretty consistent manner. There were always variations, but there was a high degree of consistency. Now, in the industry, JavaScript got little respect as a first-class language. No one was going to use this to build big, giant, robust, complicated programs. It was just for giving some added functionality, interactivity to websites. Obviously, that's changed. We're not going to go into a deep dive on it, but I will tell you in the late 2000s, like 2008, 9, 10, people started realizing that they could have the client's browser take on the responsibility to do a lot of computing tasks rather than getting increasingly more powerful web servers to do a bunch of computing and send the finished product out to the browser. They said, hey, why don't we hijack, not in a bad way, why don't we hijack the browsers and just ship increasingly complex codes or code like programs to the browser and then send them a bunch of data and have them actually do some processing on it. And that got more and more popular. And people started developing frameworks for those applications that would operate in the browser. And they even had a name. They were called front end or client side applications. And so people developed frameworks for those front end applications. Things like Ember and Backbone, early versions of Angular. You may have heard of some of these terms. And eventually, the industry came face to face with the fact that JavaScript sucked. Now, it didn't really. It's just that there were a lot of peculiarities to it that didn't make it easy to write very large, well-organized, complex programs. And so now we get to 2015. ECMA, the European Computer Manufacturers Association, and a lot of industry experts were doing a lot of work. And they released ECMAScript version 6. Because if we go up here, ECMAScript is abbreviated ES. Now again, they're not going to implement it in anything because they don't make software. But they told all the browser companies, look, we just published this. It adds a bunch of new features to JavaScript that should make it a better experience for developers. Could you please look at this and get your internal engineers to make your browsers conform to this? And that way, if that browser receives code that uses some of our new features, it'll know what to do with it. It was an adjustment period as browsers, worked really hard to implement it, the browser companies, but it worked and they were great features. Well, ever since in 2016 and 17 and 18, and now every year, they release slight upgrades, new features to the language. In fact, the releases are now named by their year: ES 2017, ES 2018. That's how you'll know them. But when you're talking about some of the cool new features in JavaScript, this line of demarcation from 2015 is really, really important. What you'll see online is ES6 plus features. That's the term you'll see a lot. And we're going to cover these. But we're going to start with the fundamentals right around here. This is where we start. The state of the language right before some of these things got dropped in. The reason for it is when you go out into the industry, you're still going to see an absolute ton of code that still uses those older features because it was used for 20 years. And there's a lot of code out there. Then, when we've got that pretty solid, we'll show the corresponding ES6 plus feature and talk about why it's better. But I want you to be able to use both. If you learn just the new stuff, when you get onto your job and see this old code, your brain is going to break. All right, how's that for enough? Is that enough background? Okay. Any questions on that stuff? Cool. All right, so now let's actually start writing a little bit of code, mucking around a little bit here, okay? All right. Let's keep this little comment stuff up here so we can type some comments in here if we want to. But the first thing is just declaring variables and assigning them a value. There's a really important lesson here. Remember how we said a computer can only do one thing at a time? Part of what I'm going to try to impart to you all the way through this training is how to think like an engineer. And in great part, engineers think like computers operate. I'm going to show you, and you guys should be typing this out, var foo equals bar, semicolon. And we're going to analyze what this is. It might look like we're doing one thing. We're creating a variable called foo with the value of bar, and we are. But let's look at what's happening under the hood inside your computer. The first thing that occurs is that out in RAM, a tiny section of memory is set aside, and it's also given a name, a unique identifier called foo. That memory location is empty, has no value in it. The second thing that occurs is we insert into that empty memory location the value bar. There are actually two things occurring here on line 5. You could just as easily write this as var foo equals bar. They do the same exact thing in the computer. Now, the next thing we're going to learn is how to at least see the output of what your work is. But there's some lessons to reinforce here as well. You guys have seen this probably a million times in every single utility, or sorry, tutorial or course or any study you've done so far on your own. Console.log. So I have a question. What is console?
Screen.
It is a screen, or rather, the way you view what's happening with this thing called console is in a screen. But let's get back to the fundamentals we talked about yesterday. We talked about the fact that inside a computer, inside a program, everything's an object. An object has appearance or characteristics, and it has behavior. The console or console is just an object. It's an object that exists automatically as soon as you start using the JavaScript language. It's built into the language. There's lots of objects built into the JavaScript language. We're going to learn about many of them. But console is just an object. It has a number of behaviors associated with it. The one that we use all the time is a behavior called log. And what that means is the object console has a behavior called log. It's a function. If you take that function and give it some content, that function called log will cause the content to be displayed in a designated output area. Now, you could just as easily use this thing without fully understanding that. But what I'm trying to do is at every single stage, reinforce the fact that the 5 fundamentals apply in every bit of code you're writing, or especially if you're trying to understand someone else's code. Everything comes down to those 5 basic elements. We have an object. It has a specific behavior built into it. We didn't make it. We didn't make the object. We didn't make the behavior. We get it out of the box from JavaScript. If we pass in some information, it'll display on the screen. Cool? Okay, now, one of the other peculiarities of this run.js is even without running console.log, it'll show you the value of variables that you make. That's just a friendly thing. It's a feature of this specific tool and it happens under the hood. Otherwise, you'd have to specifically direct that it occurs with this console.log. All right. So let's talk about this var foo. We made a variable. Great. This step right here on line 6 is called declaring the variable. This step on line 7 is called assigning the variable. We declare it and then we assign it a value. 2 separate operations. And again, in almost every language, it allows you the shortcut right here. You can do it on one line. It makes it a lot more friendly. Questions so far? All right, now, if you make the mistake of going to some place like Wikipedia, don't do this, please. And looking up what JavaScript is, you're going to see about 5 incredibly complex words in the description of JavaScript. I'm going to look one of them up. Please don't go to Wikipedia right now, because I want to explain each of these concepts as we encounter them, because they need some context. JavaScript has what's called dynamic typing. Now, typing means assigning a specific data type to a variable. That's what we're going to talk about here. So you make a variable called foo and make it equal to bar. It's pretty clear that this is a string. What if we make a variable called age and make it equal to 52? 53 on May 24th. Ah, look at that. My birthday's in 13 days. All right. What type of data is this?
Numbers.
It's a number. All right. Now, we can kind of intuit that, but I kind of mentioned it earlier. JavaScript does have some built-in native data types. Has quite a few, actually. So now that we've at least covered the fact that you don't have to specify the data type, let's at least look at, and that data type will be intuited by by what's called the interpreter, the program that's reading in the JavaScript and converting it to machine language. Let's look at some of the actual built-in data types. Again, one of the best resources here is Mozilla Developer Network JavaScript data types. And we're going to start using each one. So first, I'm going to pull this over and just show you a couple of sentences. JavaScript data types and data structures. Programming languages all have built-in data structures. We talked about this yesterday. They often differ from one language to another. Here, we're going to talk about the built-in data structures for JavaScript. Remember, you're going to make your own data structures. For example, if you were making a computer program that handled, a training institution, you would have a data structure for a student. You have a data structure for a class, for an employee. You have all these data structures. Those are user-defined data structures. What we're talking about now is built-in data structures. And again, we can use these to build other data structures. I alluded to that 2 nights ago, and we're going to do that a lot. So I said that we use what's called dynamic typing. More precisely, it's loosely typed, and we'll see what that means, loosely. and we'll see what dynamic is. The dynamic part refers to the fact that the compiler, or rather, sorry, the technical term is the interpreter. It's a computer program that converts your JavaScript into machine language. The interpreter will, on the fly or dynamically, figure out what data type. One other thing before we start writing some code, variables in JavaScript are not directly associated with any particular value type, and any variable can be assigned and reassigned values of all types. Look at that. Foo equals 42. Now I make foo equal bar. Now I make it equal 2. We've got 3 different data types right there. Now, let's not look at all the data types yet. Let's just experiment a little bit. All right. Let's just have var age equals 52. Or actually, we're gonna make it really, really simple here. 10. Now, I would like to console.log age. I want you all to follow along, okay? Now let's get weird. Var weird equals 1 plus age. Will this work? What do you guys think?
It won't like add the number 1 to age, but it'll like combine the string with the number.
Let's see. Good call. Okay. Let's try it again here. Let's do something weird here. Let's make age equal 2. And now weird equals age plus 1. Okay, everything's staying the same. Now there's one in here where it gets really, really weird. Looking this up. Give me just a second. It may take a bit to find this. Give me just a second. Oh, here it is. This is what I was looking at. Okay. So here we are. Var age equals 10. We log it. Okay. Now, watch this. I'm going to make this into a string. It's a string because it's inside quotes. Right? I mean, that kind of makes sense. But look here. Look what weird does. I'm taking 10, look at this, and I'm adding 1 to it. Shouldn't I get 11? Can someone explain to me what they think is going on here?
You made the first 10 as a string, so it's just concatenating with, it treats that as letters.
It looks like 10, but it's just a string. So can I do like age times 2? Well, did that blow your mind or what? If age is a string, how can I multiply it?
Yeah, that's a good question because you cannot add it.
It's weird, isn't it? Here's why.
The operator is what's making the difference.
What's that, Jonas?
It's the operator which is making the difference.
Exactly. This symbol right here of plus is called an operator. That word is taken from math. It's what sort of operation are we going to do? The plus operator, when we look at it, we think mathematics. But let me show you what it's usually used for. We'll do it up here. We'll do console.log. Eric plus space plus quote gross. When you're adding strings together, the word is called concatenation. That's the word for adding strings together. So here we are, we do something it's kind of odd, but it works. On line 11, we're making a variable called age. It's a string that sure looks like a number, but we know it's a string because we put it in quotes. And when we log it, it's a string. So let's think like a computer. Remember that this line 15 is 2 things. The first is declaring a variable called weird. The second thing is assigning it a value. Now, we're going to learn some fundamental terminology here that is actually pretty important to know. I'm saying that because for a long time, I didn't fully understand it. I had a hard time with some concepts. Everything inside these parentheses right here has a name. That collection of things inside has a name. Anybody know what that thing is called?
Expression.
It's an expression. Now, a mathematics professor would want to hit me with an eraser for saying this, but I find it pretty workable. An expression is something to solve. That's all it is. Now, more precisely, if you look at algebra, it usually means something where there's variables that need to be evaluated and figure out what they mean. Something to be solved works for me, but you'll see that term expression. What it means is we don't yet know what this whole thing will end up being. We need to evaluate it. The term is evaluate the expression. You'll bump into this a lot when you're doing your study or when you're learning new languages. So your computer, you've done the first part of declaring a variable. You are asked to assign it a value because you see the equals symbol. What you do next as a computer is you take both of these things together and you go, okay, I have an expression. I need to evaluate it. What's the first thing I have? It doesn't read the whole sentence all at once. It doesn't read the whole expression all at once. It reads the first thing. And the first thing is this variable called age. And it goes, oh, well, I've got that in memory. I created it right up here. And at the time that I assigned it a value, because I have dynamic typing, I determined, because of the quotes around it, that it should be a string. Okay, all right. That's the first part of this. Then it looks at the operator and sees plus, and it goes, oh, okay. I'm going to concatenate something to the first string, because right now it thinks that age is a string, because that's what it came up with when it was assigned a value. So it says, oh, great, 2. All right, well, I'm going to turn this 2 into a string because I am concatenating strings. And that's why we get line 17. Now, when we switch this, it goes subtly different for the interpreter. It does the same thing. It declares the variable. It says, oh, I need to assign it a value now. It takes this whole expression and starts reading through it. It gets the first piece of data, which is age, and it goes, oh yeah, that's a string. But then it sees the operator and goes, wait, times? All right, well, I'm out in kind of uncharted territory, except it's not uncharted territory. The interpreter has instructions that says, well, wait a minute. Don't just assume that this code can't be executed. See whether this string actually matches up against a big list we have of string to numbers. And since the string equals the characters 1 and 0, it actually goes, oh, I've got a little map in here stored in memory that equals the number 10. And then and only then will it change the type of this variable on the fly. That's dynamic typing. It changes it based on context. Suddenly, the data type of this variable's value changes. And now we can do math on it. So here's my question. If I type age right here, what do you think we're going to get? The number 10 or a string called 10?
The number, maybe?
String 10.
The dynamic typing does not permanently change the original state. To do that, you have to specify, I want to permanently change the value. Sorry. Let's do that. There's a word for changing the data type. It's called cast. It's almost like you cast it in a new mold. So let's look that bad boy up. JavaScript cast to number. Now, there's several ways to do it. JavaScript makes this pretty easy. Now I'm teaching this word cast because it's used fairly often, sometimes in JavaScript, very often in other languages that are strongly typed. You're going to encounter it. The concept's the same. We want to convert it. So here's one way. There's a built-in function in JavaScript called, and you should all be typing this, parse int. That takes a string, because remember, when the interpreter grabs a hold of this variable age, at that time, it's been considered a string, except when dynamically it needs to temporarily change, like we see on line 15. But now we're going to permanently change it. Well, we're going to change it for the log. I wonder if I could actually fully change it permanently. I haven't tried this before. Let's say age, and we're going to reassign it equals parse int age. And now just this log age. Look at that. We permanently changed the data type. Anybody not following? This class is for you. If I go too fast on something, stop me and we'll go over it again. Everybody all right?
Yeah,
Okay.
I just
ahead.
want to, so the only reason it was not working with the plus, it's because the plus is not it's not a straightforward character, I guess. It has different meanings.
The plus?
Yeah.
Yeah, the specific reason it wasn't working is that that operator means different things based on the type of information it's being applied to. If that operator is being applied to string data, and again, at this moment, the interpreter thinks that age has a data type of string.
Mhm.
The plus means a different thing. It's a different type of operation than in math.
Okay.
That was really good, Ellen. It was very insightful. All right, so now here's my question is, what happens if we console.log age plus 2? We tried it on line 15. Look at line 15. Or sorry, line 17. And we got a string of 102. It's the string 10 plus the number 2 turned into a string. What's going to happen right here if I put the number 2?
It would be turnip.
Absolutely. Alexandra, can you take a crack at explaining why it's 12?
Because of line 20, when we switched the we're casting the parse int to the age. So it's now
Exactly.
a number.
We have cast the data type from string to integer. Spot on. Now, part of the reason I'm leading you through all this is because one of the challenges when you are both writing and especially reading someone else's JavaScript code has to do with this fact that JavaScript is not a strongly typed language. With a strongly typed language, you must declare the data type at the time of creation, declaring it. When you declare a variable, you have to give it a data type, even before you assign it a value. And the language, say C# or Java, when it receives that instruction, based on the type of data you want, sets aside specific amounts of memory waiting for values to be put into it. JavaScript was built with a different philosophy in mind. They're going to set aside a certain amount. And then once they find out what type of data this variable should be, it might change that amount. Now, you don't need to worry too much about that. That's all under the hood. That's being handled by the interpreter. And the interpreter is coordinating with your operating system, because the operating system adjusts the memory. But when you're learning this and you start reading through the code, and when you declare a variable, you aren't specifically being told what type of data it is. You've got to pay very close attention to the context and know that while it's being given a specific type now, it could be completely changed later on, and you've got to follow through all the execution of the code and figure out what the type of data is at that moment. It makes it a bit of a challenging thing, but you do get used to it. For now, let it be enough to know that this kind of thing is possible, that the interpreter can look at the specific situation and temporarily consider the data type of a variable to change for certain operations. But that you can also, for lots of the built-in data types, explicitly change their data type. Questions so far?
Just one.
Yeah.
So down the line of the code, we can change that back to?
Let's do it. So it's to string, I believe. Let me go and look at that. Convert JavaScript. Wow, that is not JavaScript. Convert number to string. I think it's just to string. Here it is. Watch this. Console.log. And we're going to call a function called to string, and we're going to pass in age. I didn't do it. I called it wrong. Let me see. Oh, it's done like this. The number object itself has a built-in behavior. Remember I had said objects have characteristics and behavior? One of the built-in behaviors is to string. There we go. And that's kind of an interesting thing. Look at that. This to string, the people who designed JavaScript decided that when you have data types that aren't string, that in most cases, you'll give that data type a behavior of, hey, if you want to, you can convert this value into a string. And it becomes associated with any object of that data type. Kind of cool. So that was a good question. So now it's converted back. Now, we only did it temporarily. Let's see if it actually takes. Why don't we pull this out and say age equals age to string. And now we'll log age. Yeah, it changed it permanently. That was a good question, Sudesh. I like that. Good. How are we doing? Any questions so far?
Would it be legitimate to say this is casting types, since the syntax looks different from the former one, from the parse int?
Are you asking, would it, like terminology, you said, would it be legitimate? Your microphone's pretty sketchy. I think it sounded like you were asking, would this legitimately be called casting to a different type? Is that what you're asking?
Yeah. Yes.
Yeah. Now, there might be a different terminology in JavaScript. It's most commonly just convert. If you Google convert from number to from string to int, you'll find the actual command. Casting is another term for it, very, very common in computer science. I happen to use that one. You can say convert and it works just fine. What you're doing is you're actually changing its data type. Actually, hold on. I could be wrong about that. There's some nuance on the difference depending on the language. Let me see if I can find any kind of consensus. Yeah. There's a lot of nuance depending on the language. For practical purposes, when you need a variable of one type to be converted to another, you'll find several different ways to do it. Here in JavaScript, they're calling it conversion. So let's just call it conversion. Is that cool, Jonas?
Yeah.
Awesome.
Right.
Okay. All right, good. Now, we were going to discuss here the various types of built-in or native data types in JavaScript. Okay. We've obviously covered a few already. Let's go ahead and say here native or built-in data types in JavaScript. And we're just going to do some examples using each one. First of all, let's list out what's built in. Boolean, null, undefined, number, big integer, string, symbol. These are called primitive data types. And they are at the lowest level of the language. Almost everything else is built out of these. Let's talk about each one. So what is this? A logical thing or entity is true or false, right? We've discussed Boolean a little bit already. Let's see if we can get some examples here. So here's a simple one. var allowed equals true. Log it. Pretty straightforward, right? Allowed is a variable, its data type is type Boolean, and its value is true. Okay. However, you'll very often see this where we have something typically inside parentheses, not always, we have something that needs to be evaluated or solved. We need to determine whether or not something is true or false. Now, in order to determine whether something is true or false, we get to go way back down to the CPU and the 6 built-in logical operators. What are those logical operators? In math, we have
than,
operators like
And
addition, subtract.
or
Yeah.
not,
Okay, go ahead. What are they?
and or not.
Good. All right. So they are an operator, and an operator is applied to things. The end of an operation is an answer or a result. So the way you put this here is, here's the syntax. Operand 1 and then logical operator, and then operand 2. That's the syntax of an expression. Remember that an expression is something to be solved, which tells me that there's a direction on what to do. The middle part is what to do. The things on either side are what to do it to. So let's set this up. And let's say that we have a var of, let's see, age. Did we already use that up above? No, we didn't. We deleted everything. For our age is equal to 25. Or actually, we're going to make it 29. And var has credit card is equal to true. I want to determine whether someone can rent a car. Let's say that the law says they just have to be older than 29. That's all. Sorry, older than 25. How would I can make the expression to see whether or not that was true?
By writing if condition.
Say again.
By writing if condition.
Good. Okay. By the way, I was wrong. The logical operators are not and or not. Those are Boolean operators. The logical operators are greater than, less than, equal, greater than or equal to, less than or equal to, and not equal. Those are the 6 logical operators. I didn't even catch that when we were saying it. Boolean operators are different. Logic is comparisons. Yes, the logical operators end up with a result of true or false. Oh, I know why I used the wrong term. They're comparators. I apologize. They're logical comparators. So the syntax is logical comparator. Now, you're hardly ever going to use those terms, but you need to know what we're doing. So I need to make an expression here. I need operand 1, and then a comparator, and then operand 2, and it's all got to go inside here. What are my operands? You have to be greater than 25 to rent a car.
Age is greater than 25.
That's it. And we get true out of that. So this is working. So again, operand 1 is this variable called age. the current value of which happens to be 29. Operand 2 is the number 25, and the comparator is greater than. So let's look at what happens in terms of the interpreter on line 29. First thing, we declare a variable called allowed to rent car. We have not dynamically typed it yet. Right now it has no type. Well, now we're going to assign it a value. And during the assignment process, where we assign it a value, that's when the interpreter will dynamically figure out what data type it is. So it looks at age, which in this case is a number, 29, and it looks at this operator or comparator. It says, oh, this is a greater than comparator. All right. If I have an integer here, a number here, let me look at the third one. It's a number. I can actually evaluate this expression. That's the terminology. Here's the expression. I can evaluate or solve it. It solves or evaluates to true, because that's what happens when you do a comparison. Therefore, the data type of this variable called allowed to rent car is Boolean. Now, let's see what happens when we make it a little more complex. What if both of these have to be true? Now we're looking at Boolean operators. How do you think we can change line 30 to include the fact that you also need to have a credit card?
By adding the end operator.
Say it again.
By adding the end operator.
Good. We're going to add an and operator in here. Now, part of the reason I'm stressing like what the definition of an expression is and what its parts are is because another thing that can be really challenging when you're trying to figure out these Boolean things is how and where to put all your parentheses and make things work. Well, let's look at the syntax. We're going to evaluate a Boolean expression. And it looks like this. I'm not using the correct terminology here. A mathematician would probably kill me. On the left is some piece of data that's either true or false. I'm going to call that a binary datum. You might call it a Boolean datum. It's a piece of data that's true or false. And here is one of our operators, and, or not. So what's my Boolean datum of can be true or false if we're trying to figure out whether to rent them a car? What goes on the left?
Less than 29.
What's that?
Less than 29.
No, the requirement is that they're greater than 25. So let me put the rules here. By the way, I'm using this one because for a long time in America, it was true. And it was a real pain in the ass before I was 25 years old. So that's the rule. So I need to have, clearly the Boolean operator is and. We know that because they both have to be true. So what goes on the left? What do we want to figure out whether it's true or false?
Age is greater than 25.
Excellent.
And
now we need our Boolean operator. In JavaScript, and in lots of languages, a double ampersand means the Boolean operator and. Some languages, like Python, you actually type out the word and. I think it's kind of cool. All right, what's on the right? What's the other expression or piece of datum that will be either true or false?
has credit
Credit
card.
card.
Right, we know that that's true or false. Look at that. We did it. We got true right down here. Now watch. Suddenly, my credit card got taken away. Sorry, look at the bottom of the screen. You can't rent from us. Or, I have a credit card, but I'm 14. Dude, you can't even drive, let alone rent a car. So understanding the difference between these logical comparators, which will always result in a true or false, and the Boolean operators, which evaluate two possibilities and return a true or false, is important. They both operate similarly, but you need to figure out what's actually being done here. Am I evaluating a Boolean operator? Am I evaluating a comparator? If I'm evaluating a comparator, is it only so I can get a true or false result to use in a Boolean operation? All right, how are we doing? Any questions on this? All right, let me show you something else kind of cool. Watch this. Console.log, you should all do this. Really? Why are you going undefined on me? You're killing me. There's a type of function which lets you print out the type of data. All right, well, let's do age. All right, that's a number. Oh, it's a peculiarity of JavaScript. Boolean is undefined until you actually use it in some kind of an operation. I forgot that. So we can have one here. Let's do another var. This is string. And then let's do type of foo. And now it's a string. You can find out what type of data something is at that moment. You don't have to guess. There's a way to figure it out. All right. Okay, cool. Okay. Let's see what other data type. We'll do one more type of data before we end off. We've looked at Boolean. We'll look at null in some detail later. It is its own type, and it only has one value, which is null. We're going to look at that in a bit. Now, this is important. Undefined is a variable that has not been assigned value. Let's see that. Let's go to the bottom here and move things up a little bit. Remember how I said we can take the variable declaration on one line and then the assigning on another line, right? Now, look on the right here on line 42. This is the result of our type of. Look at line 42 and the type for the variable called foo. What is it?
Undefined.
Exactly, because we have not yet assigned a value. This actually comes in extremely valuable when you're trying to debug your JavaScript code. When you're looking through your code and you look at the value of a variable, expecting to see something, and you see undefined, you need to go right back to the actual assignment operator. Find the exact point where you tried to assign a value. Something broke there. So it helps you spot the exact area in your problem that has the code. Okay, good. I think that's enough because we're coming up on 8:30 and that's a long stretch of this stuff. When we meet again, we're going to talk about numbers and the difference between that and a thing called the big integer, and then strings and then symbols. We're going to learn all these primitives. Now, it's pretty important to understand all these fundamentals here because these are what you use to build your own data structures. So you need to know how they work. Finally, there's one thing I want to point out, which is that every single one of these, when they get created in memory, every one of these variables is in fact an object. And an object has two aspects to it: characteristics and behavior. The characteristic of this one on line 26 is its value. The behavior of it is math behavior, like plus, minus, multiplication, all that, and a toString behavior, which we saw we could do. And you'll find similar aspects of every single one of these data types. Every variable you create, no matter what data type it is, under the hood, it's an object. It will have various characteristics and various properties. Those are the things you need to learn. Specifically, some of the properties. All right, good. Any questions? Awesome. All right, cool. Okay, discussion about schedule. I'm going to be in Boston all next week for a business trip. And unfortunately, on Monday, Tuesday, and Wednesday, teaching a class that starts at 5 in the morning, Boston time. And then as soon as I'm done with class, I go into meetings. I'm going to be toast. So we're going to have to skip a week. I am going to assign you some basic JavaScript tutorials to go through. I've researched some of these very thoroughly. They're ones that I feel pretty good about, particularly since we laid in some of these fundamentals of what dynamic typing is, some of these basic built-in data types, and the 5 basic elements of a computer program. So let me show you the tutorial I'd like you to work on in just a minute. And I want to explain a couple of things you'll see right on the front page, and then I want to turn you loose with it. So go ahead and grab that link. In fact, I will put it in Discord. Homework for the next 2 weeks, because we're going to skip a week. Okay, good. All right, so now let me pull this over onto my screen and show you a couple of things in it, okay? All right. We aren't studying yet a lot of elements of JavaScript in the browser. But it mentions a couple of things right at the top here, and it's fine to mention them. It mentions a thing, well, it mentions ECMAScript, which we've covered about, we've talked about already. That's the specification for this scripting language. It also talks about a thing called the document object model. We're going to talk about this in great detail in our web section, but here's a basic description. This is an object. Again, what do objects have? Characteristics and behavior. It's an object that your browser holds in memory. And it represents the web page. All of the elements that you made in HTML. All of the available behavior, like your JavaScript code that could be executed. Built-in JavaScript functions. All of that is on that object. So the characteristics of it are the individual elements on the page, everything about them. The behaviors are built-in JavaScript functions that are meant to work with the elements on the page. Other behaviors are your own custom JavaScript code. Now, we're going to get into that in a lot of detail in our web model, but I want you to at least have an understanding of this. Fundamentally, your browser reads through your HTML document and makes an object in memory from it. Any questions about that concept? Okay. This browser object model is a separate entity held in memory that other computer programs exterior to the browser can use to interact with it. Just so you know what it is. It's a way the browser lets other computers work with it. Everything else on here is pretty darn straightforward. It talks here about a JavaScript engine. That's essentially the interpreter that we're talking about. It converts your JavaScript code into machine languages. So it's a little more complex than an interpreter, but it's what it does. It converts your JavaScript code into machine language. And when they use the word bytecode, that's another word for machine language. Yeah, there's some nerdy difference and nuance there, But essentially, think of this machine language. Everything else in here is pretty straightforward, has some of the nerdy history, JavaScript, JScript, European Computer Manufacturers Association, and then a review of some of the stuff we've been talking about. But it rapidly adds on complexity that I feel like you're ready for now after these last 2 sessions. So work through this, frankly, as far as you can get before our next session, which will be, pull up the calendar, the 23rd, 12 days from now. Any questions? Okay, cool. Awesome. All right. Now I'll be watching Discord. If you need anything at all while, during the next week and a half, just ping me and I'll help. All right. Okay, cool. Have a great night, folks.
You
Thank
too.
you.
Evening.
Bye all.
Thank you. Bye.